Okay, welcome back to the next latest and greatest book review webinar. And I want to pick up where we left off here with the C++ textbook here by Malik. And this webinar is meant to help bridge the gap between the textbook material and what a lot of my students in the past have been confused about, number one, as well as hopefully provide some good information back to the publisher concerning any of these sections that I feel is confusing. So hopefully this is a win-win for everybody. But I do want to pick up where we left off in chapter 2. We were on page 1 here talking about type conversion, and I believe I covered this pretty well in the last book review webinar. But the key to 5.1 is that we have several different numeric data types, right? We have ints or integers, we have doubles, which is essentially a floating point number, and we can take an integer and convert it to a double, or we can take a double and convert it to an integer using something here called static casting. And again, I believe I covered all of this pretty well in the last one, so I don't want to go over this here. So I'm going to move on to the next page here. All right, string types. So we learned about the different data types that we can use to represent numbers. Well, we also need a data type to help us represent any kind of information that is not numerically based, right? And this is typically a sequence of characters, for instance, a name, or maybe any alphanumeric text that is useful in describing something or presenting information to the user. We want to utilize a string. Okay, the only caveat to that is if you want to use the information in a, let's say, formula or do any kind of math operations on it, then you need to use one of those numeric data types that we just talked about a second ago. But strings are very common in a lot of applications. And the way we represent strings in C++ and also 99% of the other languages out there is we use these quotation marks around whatever the information is that we want to store. And these quotation marks let the compiler know, hey, this is non-numeric information that we need to store in memory. And if you forget these quotation marks, well, then the compiler gets confused and it thinks, well, maybe this is a variable, or it thinks maybe this is a keyword. So definitely the key is using quotation marks around whatever your non-numeric data is to let the compiler know, hey, this is a string. So these quotation marks are going to become really important because they let the compiler know where the string starts, which is the open quotation mark, and where the string ends, which is the close quotation mark. Okay, that is what a string is. The next thing they want you to learn about, so now that we know about these numeric data types and these non-numeric data types, aka strings, well, how do we go about creating variables or mathematical statements or equations that we can use with these data types and with these values? And that's what this next section of the book is. Okay, so let's take a look at that. And I'm always confused as to why a lot of textbooks, when they start to talk about declaring variables, they always start with constants, and that confuses a lot of students. So I'm going to kind of scroll down here to the second part of this page. And this is, I think this is a better place to start when we're talking about variables. Okay. The idea is that we can declare a variable using a particular identifier, and then in front of that variable name, we put what type of data that needs to be stored inside of it. So anytime we're declaring a variable, we want to use the data type, give it a good name, a valid name, and we'll talk about what's valid and not later on, and then a semicolon to denote that is the end of the statement. So that's why you're going to see down here in example 212, right? Here's the data type. Here is the variable name. Here is the semicolon. This is probably the most common way of declaring a variable. Now, it is optional that you can use commas in between variables, and that's what they're demonstrating here with this int xy. You see how they put a comma here? That basically means, hey, there's a variable called x that is an integer, and there is a variable y here that is also an integer. So, but I will say this, that in industry, typically, you want to see each variable declared on its own line. It makes the code much more readable. And especially when you're using nice, long descriptive variable names, you have, one line for each variable declaration, and you don't try to shorten things, right? Giving variables these short little names like this, and that is what programmers used to do back in the olden days. Okay, they had these very limited systems with very limited memory, and they had to give variables these nice short little names. And also a lot of math majors come over into the computer science world, and they're so used to using these little variables in their math equations that they like to do so in their computer programs. And that's not really good programming practice. You want some nice nice descriptive variable names like amount due. This is good. Counter. This is good. Name. This is good. CHXY. This means nothing and will confuse everybody. All right. But back to the original statement, data type, your variable name, and a semicolon to denote that is the end of that line. Okay. Right. So that's how we can declare variables. Now, the reason I mention this is because back up to the top, a constant basically just means you're declaring a variable, right? Same format as we discussed below. Here's the data type, here's the name, here's the semicolon. But notice that with a constant, you're actually initializing the variable to a very particular value, number one. And they talk about this a little bit later on in this chapter. But when you declare a variable, you can go ahead and assign it an initial value, and that's what they do here. But the second thing that's important about constants is that it represents a variable and a value that should never change in the application itself. Okay, for instance, number of students, maybe that class always has 20 students in it. This variable called blank, well, it's always a blank space. Okay, I think a better example, note to the publisher, of constants is like the value of pi. Okay, or even this convert, right? Pi has to be 3.14. So typically pi is a great constant to use as an example. Same with this conversion. Well, what conversion is this? I think this is inches to centimeters. Well, why not call this, and I'm just guessing there, inches to centimeter conversion, right? Use a nice descriptive variable name here explaining what in the heck 2.54 is. But bottom line is constant. Anytime you declare a variable with const in front of it, that means this variable cannot change value ever in the program. And it's a way to protect it, okay? Because maybe another programmer comes in and starts messing with things and wants to change that variable to another value. This constant will prevent that. The compiler will go, no way, you can't do that. This variable is a constant. Why are you trying to change it? Okay. The other good convention about a constant is using all uppercase letters. Okay, and that's what that's good programming practice. Anytime you have a constant variable, you should use all uppercase to name it, and that lets anybody using the variable know, oh, I can't change this variable. It's all uppercase, therefore it is a constant variable. All right, so that's what this section's about, declaring variables at the bottom, and then how do we make it that variable value unchangeable using a constant identifier. All right, let's go on to the next page here. Right, and again, they kind of, again, note to the publisher, we're bouncing around here. We've already seen some examples of putting data into the variables, and now we're kind of starting over from scratch here. But yeah, let's talk about putting some data into the variables again. And we will see that here, right, we learned about in the previous section how we can declare variables with their data type. We put a semicolon behind it, and this will declare these 1, 2, 3, 4, 5 variables in memory with these data types. And then we can use what's called the assignment operator, or this equals sign, to take whatever's on the right-hand side of the assignment operator, or the equal sign, and put it into the variable declared on the left-hand side of that equals or assignment operator. Okay, so when the program runs, and this is a sticking point for a lot of students, is that sometimes they'll even reverse this. They'll say 4 equals num1. And when you're new to this, that seems like it should be the same, right? Num1 equals 4, 4 equals num1. It's the same thing. Well, not really, not to a computer, because the computer always expects the variable to be on the left-hand side, or the assignment variable to be on the left-hand side, and the value to be on the right-hand side. So when you're new to programming, make sure that you remember that, because if you try to reverse the order of these values and variables with this equal sign, you're going to get a bunch of compiler errors. Okay. So here we've declared variables. Here we're assigning the variables a particular value, and they give us a good example of this. So right now we've been just looking at little snippets, right, of each line of code, and that's so that we can kind of focus in on each line. But here, this is an example of an entire C++ application that will actually run, right? In theory, we should be able to copy all of this code to, let's say, the Visual Studio C++ environment, or any C++ IDE, and it should be able to compile this program and then run it successfully. And so a lot of students, what they like to do is they like to grab this code and they like to start typing it in, and they feel like a programmer. And yeah, that is exciting and it is fun, but what I always recommend is you need to learn how to read code before you learn how to write code. Just like in elementary school, they teach you how to read first before you're ever really writing words and full sentences, right? So what I usually like to do with these examples is let's make sure that we can read this and understand this and figure out how this output, when it says sample run, note to publisher, maybe put a little note that this is the output from this program. This is what's displayed when we run this. Now the question is, well, why? So if we look at this code, remember every program starts with main. So this main method here at the top lets us know, okay, this is the beginning point of the program. It's going to find main and it's going to execute everything inside of main. Towards the end of this chapter, we'll talk about what this stuff here means at the top, but just know that, for now that we just have to do it. Okay, we'll talk about this later on. Here's the code, and all of this code here should look very familiar to what we just learned on the last few pages. We have 5 variables being declared at the top of the program. That is good programming practice. Typically, you always want to put your variables at the top of the function. Well, not only typically, the compiler, if you try to use these variables before you declare them, the compiler is going to freak out, and it's going to throw all sorts of compiler errors. Okay, because computers are stupid machines. You always need to declare your variables first before you can use them. And that's what we're doing up here. Also remember that computers, another confusing point to a lot of students is that computers run top down, right? This code is nothing more than a sequence of steps that needs to occur in order. So it's going to execute this first and declare num1 and num2 in memory as an integer. It's going to execute this line next, where we're going to create another variable called sale. That is a double. A double is a float, basically a value that has a decimal point in it. Then it's going to create another variable called first in memory, which is a char or a character. That basically means a single alphanumeric textual value. Okay, so we're going to create another variable called first in memory that is a character. And then we're going to create another variable in memory called stir, which is a string variable in memory that I assume is going to at some point store a string. Okay, so again, top down, right? We're creating these integers, we're creating this double, we're creating this character, we're creating this string variable, and then we hit this line of code, num1 equals 4. All right, so in memory, it's taking this number 4 and putting it into this num1 variable, right? So now num1 has the value 4 in it. Then it goes to this line of code, cout. And I don't even think we've talked about cout yet in this chapter. I think it's mentioned later on. Let me verify that. I want to say they talk about this in a little more detail here in the output section. But cout basically means that you're outputting values to the C or the console, right? Back when they C++ and C is a very old language. So again, you'll see a lot of these shortened abbreviations that are terrible names. So you just need to know that cout means basically a print statement, okay, or console output. And what it's going to output is anything after, I think this is called a redirection operator. It basically says take whatever value that is on the right-hand side of this redirection operator and send it to the statement on the left, kind of like a flow. And again, a lot of students get very confused by this. This is why C++ is probably one of the tougher languages to learn compared to something like Python, because it uses a lot of these abbreviated function names, a lot of these overridden operators, and anyways, that's what it means. Okay, so what this is going to do is it's going to print the string num1 equals, right? Notice there's a quote here, quotes around num1. That means it's going to print out num1, but here there's no quotes around num1. So what that means is that it's going to go into memory. Remember, num1 is equal to 4, and it's going to replace the number 4 here with num1, and then end L. End L basically means end line, and what that does is that forces what is printed on the screen, the cursor, to go to the next line before it starts printing any more values. Without these end L's, all of this output would be on the same line. All of this output down here would all be on the same line, and it would make things unreadable. So yeah, typically at the end of every cout statement, you add an end line or an end L. That is an L, not a 1, end line. And that causes the cursor to go to the next line. Okay. All right, so this num1 equals 4 is how we get this first line of output. Then it executes this next statement, num2 equals 4 times 5 minus 11. Remember, it always executes what's on the right first, and then it'll put it in num2. Well, what's on the right, we have 2 operators here, right? So does it do 5 minus 11 first, or does it 4 times 5 first? And if you remember back in math class, there's something called PEMDAS, right? Please excuse my dear Aunt Sally. That means that the multiply is going to run before the subtraction. So 4 times 5 is 20, 20 minus 11 is 9. That is why you see num2 is equal to 9 here. Next line, sale equals this. Okay, so it's going to execute, whatever this is. I think 1,000 times 0.02 is 20. And that's going to put it into sale. And then it says, okay, we'll print out sale equals, right, between quotes, the variable, the value of sale, which is equal to 20, because that's what this line of code did, and then go to the next line, and that's where we get sale equal to 20. So we do this, multiple times. Notice that the first variable is a character variable. That's why we're only assigning one character to it. If we were to try to assign more than one character to this variable called first, yeah, you'd see a compilation error because it would say, hey, that's a string, and you're telling me that this is a character. I can't fit multiple characters into this first variable. Okay, so we take a single character, we assign it to first, and then we say, okay, print out first equals between quotes, and then print out the value that's in first, and that's why we see first is equal to D. And then the next line of code, it is a sunny day, right? This is the string in between quotes. We are assigning it to the variable str. Str is a string, so that will work. And then we print out or see out string equal to in quotes, right? String equal to in quotes, str, which is the value inside of str, which is it is a sunny day. Okay, so great example here. And if you're new to programming, yeah, a lot going on here. Well, and I guess just as a final note, this return 0, we're going to learn later on what this return 0 means, but just know for now that anytime you declare main, you're going to need a return 0 at the very end of the main method in order to keep the compiler happy. And we'll go into more detail about that later on. But you see how to declare variables, you see how to assign these variables values, you see how to print out or see out whatever is inside of these variables. And you should be able to look at this code, read it, understand its behavior, walk through it, and also understand why it outputs this down below. Okay. So good example here, and make sure that you're comfortable reading this before you write it. Okay. All right, what else we got here? Yeah, I think they're basically going over what I just said here concerning the variables and what goes on the left side, what goes on the right side, but I've already gone over that. I will say this, that there's something called desk checking, where when you're reading and interpreting code's behavior, you may have code with a bunch of values like you do up here. And it is beneficial to take each one of these variable names and list them on a piece of paper. Okay, so that you can have a way of keeping track when you're reading the code and interpreting its behavior. As you go through each step of the code, each step may modify one of these values, right? Each step may modify one of these variables and put a new number into it. And that is critical, because at this point, num1 is equal to 18. But notice that all of a sudden in step 2, num1 changes its value. Here, it adds 27 to itself. And in step 3, you're saying, well, num2 is equal to num1. All right, well, is num1 equal to this, or is num1 equal to this? Well, because this is the third step, num1 has to be equal to this. So the idea is that as you run each step of code in sequential order, top down, you're updating whatever is inside of the variables on paper. And obviously the computer, as it runs the program, right, is going to be updating whatever's inside of the variables in memory. Okay, but again, the computer's no smarter than the piece of paper. They're dumb machines. Whatever you tell the computer to put inside of each one of these variables, and whatever order you put these lines of code in, is going to determine what number goes where inside of these variables. And if you shuffle these, if you start to move some of these lines of code around, and let's say put this fourth step up here on underneath the second step, you're going to get completely different behavior. So programming is all about attention to detail and realizing what each line of code does to each one of these variables in memory. Okay, you can't just look at, let's say, a snippet of code and boom, oh, I know what that does. No, even for me, you present code to me and I'm going to say, give me a second, because I have to read each one of these lines one at a time, figure out what this line does before I can even look at these lines, because these lines might be dependent upon any of these previous lines. So that's what it means to know how to read code, is that you're stepping through it line by line. And later on, we're going to see that there is something called a debugger within the IDE, within, let's say, Visual Studio or whatever your C++ IDE is that you're using. And we can watch the computer step through each one of these lines one at a time. But I'm saying it is also good to know how to do this just visually in your head before, because the thing is, when you're stepping through it with the debugger, every time you hit step over with that debugger, you need to ask yourself, okay, does that make sense, what I'm seeing with that debugger? And if it doesn't, then you've got a bug somewhere in the code. And you have to troubleshoot whatever that bug is. So if you can't visualize in your head what this code is doing, well, when the code runs, you're not going to understand where the bug is or why the bug is. Okay, so reading code and interpreting its behavior is critical. All right, enough about that. Let's go on to the next page here, which is about, same kind of thing that we just talked about a second ago, declaring variables and assigning those variables to an expression. And notice that in these expressions, you can use, so for instance, we have a D variable here, using what's inside of the B variables, using what's inside of the A variable, using what's inside of the C variable. So you don't just have to use numbers and strings. You can actually use other variables that have values inside of them, right, to help you determine the value for the for the variable on the left-hand side of the assignment operator, right? Because we always execute what's on the right side before we go and assign that value to the variable on the left-hand side. Okay. Now, I think what they're trying to convey here with this example is that if in your math class they give you an equation like this, negative b plus b squared minus 4ac, or negative b minus b squared minus 4ac, how can you convert that into, let's say, a programming language or code? And they're basically saying, well, you got to break it up a little bit, right? B squared minus 4ac is in parentheses, so you want to do that first, which is why you see b times b minus 4 times a times c, and they assign that to d. And then the second part is, well, add this to negative b, and that's what they're doing here. X is equal to negative b plus d, right? This d is this guy up here, which is b squared minus 4ac. So you can use these intermediary variables in order to store temporary values to help you with the next step of the equation. Same here, this negative b minus this value is what y is equal to. Y is equal to negative b minus this b squared minus 4ac, which is stored in D, which is why we put that here. Okay, so I think that is the point of this page here. And there is a lot of math here, and this does tend to scare a lot of students. The reason there's a lot of math is because we're talking about all of these different numeric data types and how to use this assignment operator. Just know that there are plenty of data-driven applications out there that require very little math. So at the end of the day, if some of this math scares you, just try to grasp the high-level concepts of, the data type and the variable and assigning it a value. And that should get you 90% of the way there. Now, obviously, there are lots of applications that are very math heavy, but there are just as many purely data-driven applications that involve very little math. So my point is that if you see some of these math examples using math and they scare you, just try to look over it real quick and then move on to the next section. Okay. All right, so in this next page here, another example where we're declaring variables, right? And then we take those variables and we assign them values. These look like legitimate values. 13 is an integer, 10 is an integer as well, so that's okay. CH is a character, has a single space character, that looks good. 12.6 is a double. I see what they're trying to present here. Notice that it took 7 lines, 8 lines of code to declare these variables and initialize them to a value. You can combine declaring the data type, the variable name, and the value all on one line. So we can take this code here that has this information, and we can condense it such that it only takes 3 lines of code to declare these variables and initialize them to a value instead of 8. All right, so if you know the variable's value, initially, you can do this. If you don't know the variable's value initially, you can just do this. But either way, this code runs the same. It does the same thing. Some companies have coding standards that maybe they would force you to do this. But I don't know. At this point, when you're just learning C++, it's really personal preference as to which way you want to go here. Okay. All right. Input. So we talked about cout, which stands for console out, which is basically the print statement. Okay. Now let's talk about cin, which stands for console in. And cin is a way of obtaining input from the user. And typically, it's a single variable, which is why this is grayed out. But you can input more than one value from the user at a time, and we'll talk about that in a second. But this is the basic format. cin, notice that instead of less than, like we had with cout, we have greater than. Okay, so it is another redirection operator, but it's going the other way. We're taking whatever the user types into the keyboard, that ends up within this cin guy, and we're pushing it into the variable, whatever variable it is that we call out here. Okay. Oh, I'm sorry. Technically, it's called the stream extraction operator. I think in command line environment, they call it a redirection operator. All right, so we got the cin statement, we got a couple of greater than signs, and we call out the name of the variable that we want to put that information inside of. Here's a better example, CN miles. So whenever the user types in a value on the keyboard and hits enter, then that value is going to be placed here into this miles variable. Now keep in mind that if this miles variable is an integer and the user types in a string, let's say a bunch of letters, and hits enter, you're going to get what's called a runtime exception, because that confuses the heck out of the computer. It goes, well, you told me that's a tangent. Let's go over that later on. The basic format of the input statement is CN greater than, and the name of the variable that you want to write the value to. Okay, so for instance, let's say we create a couple of variables called feet and inches that are integers, and we run the program, and the program says, well, CN feet and inches. Notice that we can ask the user for 2 pieces of input at once. Now, the problem with this is that the user does not know that, and the user might try to enter only one value, and the program's just going to sit there and do nothing. It's not until the user enters 2 values, and you can either hit enter after, I think you can hit enter after each one of these, or you can put in one value, put a space, put another value, and then hit enter. And CN is smart enough to look at this and go, okay, 23 goes in the feet, 7 goes in inches. Okay, so it's going to take whatever the first value was, put it in feet, whatever the second value is, and put it into inches. I think it's better programming practice to ask for each value one at a time and say, look, please enter feet, and you type in the feet, please enter inches, then you do a CN statement for the inches. Typically, when you request more than one data value from the user at a time, that causes confusion. All right, but it is possible to use the CN or the input statement to obtain more than one value at a time. They give us another good, this is a full C++ example, right? Has the main function, has all the good stuff we need. This in its entirety will run within your C++ IDE, and it'll start at main, right? Every program starts at main. I'm just, let's make sure that we can read and interpret this code's behavior. It'll declare a couple of integers called feet and inches. Notice it's not assigning them a default value. Then it's going to ask, it's going to print out to the screen. It's going to see out, enter 2 integers separated by 1 or more spaces. Notice how clear you have to be. And even then, even users that are given this prompt will still forget the space, or will forget that more than one value needs to be entered. So again, little risky asking the user to do more than one value at a time, but that's what they do here. Enter 2 integers separated by 1 or more spaces. And then they use the CN or the input statement. Whatever 2 values that the user types in is going to go from here into feet and into inches. We're gonna see out or print an end line so that the cursor, right after you type in 23.7, the cursor goes to the next line. That's what this endl does. And then we're going to print out feet equals, and whatever value that the user typed in the feet, right? That's what we're going to print out here is the value that's inside of feet. Feet equals 23. Why 23? Because the user typed in 23 here. We're going to do an endl, go to the next line. We're going to print out inches equals whatever value the user typed in for inches. Well, the user typed in 7 here for the inches. So that is why we see inches equal to 7. And then we do an endl, which is end line, goes to the next line. And then we return 0, which is what every main method needs to do. And so that's why we see this output. Again, be comfortable reading this code before you write it and see it run on the screen. Reading is just as important as writing code. Here's another good example. Yeah, this is probably a little more real world, right? We're declaring 4 variables: first name, last name, age, and weight. So we have 4 variables. We're not initializing them. We're not setting them to any value. Why? Because we're going to let the user type that in. So we create our variables with their particular data types. We print out, this is called a prompt. Before we ever do an input statement, we tell the user what it is that we need them to input, because otherwise it's just a blinky cursor on the screen and they have no idea, right, what in the heck it is that we want them to type in. So we give them a prompt. Well, please enter the first name, last name, age, weight, and make sure to separate all that by space. It's guaranteed somebody will get this wrong and put in 2 values, or maybe 5 values, or maybe they forget the spaces altogether. So again, a little risky to me asking for all 5 at once, but we do have the capability of doing that, or all four at once. And so underneath of this prompt, we provide the input statement, and we say, well, grab the first and second value that the user just typed in, separated by a space, and put it in the first name and last name. And then grab the age and weight, the third and fourth thing that the user typed in, and put it into the variables called age and weight. As a side note, you can move all of this on the same line as here, line 13, and say first name, last name, greater than age, greater than weight. It's really up to you if you want to divide these up or not. And again, my preference is enter first name, then C in first name, enter last name, then C in last name. I wouldn't have the user do all of this at once. Okay, so we input the 4 values that the user types in. We print out the name, a name string or a name prompt, and whatever values in first name. We print out, then we print out a space, and then we print out the last name. Okay, so if we want a space in between the first name and last name, notice that we have to add the space character here in between quotation marks. And then we add the end L, which is end line, to push the cursor to the next line. And that's why after the user types this in, we see name, Sheila, man, and it goes to the next line because of this line right here. Then the next statement says, okay, print out age with the whatever values inside of age and do an end line. That's why we see this here, age 23, right? User typed in 23 here. That's the third value. So that's why that third value here went into age. And then the last print weight, and we, whatever the user typed in the weight here, that value goes here, and we do another end line to go to the next line. And that's why we see this as the output. Here's the prompt, here's the input from the user. Okay, but this is a full C++ program that should run in any IDE. But again, I like to read it and figure out its behavior first before I always suggest reading it first before putting it into, let's say, an IDE and pushing run, right? Because we need to verify, you need some way of verifying that the code is doing what it's supposed to do. Okay. Okay. Let's go to the next page here. This is a long chapter. All right, they talk about variable initialization again, and we've kind of already gone over that. Here is a variable called feet. Here's one called inches. They are both integers. We initialize feet to 35. We initialize inches to 6. And then we print out the total inches if we have 35 feet and 6 inches. Remember that 12 feet is in an inch. That's why they do 12 times feet plus inches. Also, I think what they're trying to show you here is that you can perform, a math operation inside of the print statement. Okay, that is definitely possible. Here, another way to write the same program. Notice that up here, we're hard coding what feet and inches is inside of our program. Here, we're asking the user to enter feet, asking the user to enter inches. We store whatever the user types in feet. We store whatever the user types in inches. And then the last statement we print out, well, total inches is equal to whatever the user typed in for feet, whatever the user typed in for inches. So if they typed in 10 feet, 2 inches, right, that'd do 12 times 10 plus 2. So this program here is much more useful because it allows the user to type in the specific feet and inches versus this program here where you have to be a programmer and you have to go into the program and change the values before the computer is going to help you out. All right. But again, this is about variable initialization, so not really sure how that fits in there. Note to publisher. Okay, what else we have here? Another example, 1, 2, 3, 4, 5, 6, 7 variables. Everything from an integer to a double to a character to a string. They, instead of listing the code, they show it as a number of steps, but you could probably take these same 10 lines and remove these line numbers, and it should be valid code. I guess the point that they're trying to make here is that order matters, right? Because notice that they, so here's what they do. They take each one of these 10 steps, okay, and they list, what they should do is take these 10 steps and list them down here in the table next to each one of these. But what they're trying to show you is after you execute each one of these steps, what values go inside of each one of these variables. And that's part of that desk checking strategy that I told you about earlier. When we're reading and interpreting this code's behavior, when you have a lot of variables like this, yeah, you need to have a piece of paper and pencil and you need to write down each variable name. And as each step is completed, write, write on that piece of paper what each one of those variables is equal to. So for this first step, it's putting the value 1 in the count. So that's exactly what they do here. They put the value 1 in the count. This next step here is taking, okay, this confuses not a lot of new students to programming as well. Count equals count plus 1. And they go, well, I don't get it. Counts on both sides. What this means is you execute what's on the right-hand side first. Notice that count was equal to 1 because of this step 1 here, right? So count is equal to 1. So it's going to say, well, what's 1 plus 1? That's 2, right? So it's going to take 2 and put it into what's on the left-hand side of the assignment operator. So count is equal to 2 after step 2 here. And that's why you see this table here being updated with count is equal to 2. Oh, here's the steps right underneath. So count is equal to count plus 1. Then when we execute step 3 here, notice that step 3 modifies length and width. And assuming that the user typed in 10.5 and 4.0 for the length and width, it updates the variables in memory, length and width, to 10.5 and 4.0. Notice that we keep that count variable set to 2 because it's still there, right? We didn't modify it in this step, but we're not going to lose that value either. It's gonna stay equal to 2 until something changes it. Step 4 is area equals length times width. So it takes these two values, length and width, right? Calculates and puts whatever that is, 42, right? 10.5 times 4 is equal to 42, puts that into area. We update what's inside of area, and that's what they're doing here. And if you get an assignment question or a test question based on a lot of code that has a lot of variables in it, this is what you want to do. You want to make sure that you write the name of all the variables down on paper and make sure that you write their current value for each step, top down. Okay, because notice that, let's see, does count ever change here? Aha, notice that length goes from 10.5 to 12.5 here, right? So, we can't, a lot of students that are new to programming, they'll look at these programs, and when they go to look for the answer to a question, and the question involves code, they start looking for one line of code that's going to help them answer that question. And that's not the way computers work, right? They start at the top of the program and they execute every single line of code. And so if you're not looking at all of these steps one at a time from the top to the bottom, you're not going to be able to answer that question, right? It's not like looking for a keyword in a passage, in a reading comprehension test, and then you kind of read around that keyword to figure out the answer. For mathematical equations, for computer programs, you have to start at step one and execute all the steps before you understand what that entire program is going to do. Another reason why reading and interpreting code's behavior is so important before you write it. You need to have an idea in your head as to what all the steps do before you let the computer try to do it. All right, increment and decrement. So a lot of the older languages, well, I guess newer languages too. This is very common in the programming world where you want to increment a variable by 1. And a lot of loop counters do this. It's just a very common situation where you want to take a variable and increment it by 1, usually within a loop, but there's other reasons as well. And so this became so common that they created a shortcut version of this. However, I will say this, that I like to see this, even in industry. This is very clear as to count as being incremented by 1. Here's the shortcut. There's a pre-increment, post-increment, pre-decrement, post-decrement. This means count equals count plus 1. This also means count equals count plus 1. However, again, if any of this confuses you down here, just as long as you're comfortable with this statement, you're fine. The only reason why you might need to know about this is that some of the legacy applications, some of the legacy programmers like to do this, where they use increment and decrement. And if you get some legacy code and you have to modify it, well, you're going to have to understand what this means. All right. So let me try to explain it, but it does confuse a lot of students. Let's take some examples. X equal to 5. All right, fine. Let's assume X is an integer, data type. It takes the value 5, puts it into X. This next line of code says, well, Y is equal to plus plus X. Well, this is the pre-increment, what the heck do they call it? Pre-increment operation. And what this means is that I believe, yeah, Y is going to be set to whatever's in 5 first. I'm sorry, whatever's in X first, which is the value 5, right? So Y is going to be set to 5, but after Y is set to 5, then it increments X by 1, and then X is equal to 6. However, down here, if you use the post decrement operator. X is equal to 5. Well, that's fine. Here, where it says y is equal to x plus plus, it does this first, sets x equal to 6 here, and then it assigns it to y. So at this point, y is going to be equal to 6. And maybe I actually reversed it. Let me take back what I just said. In the pre-increment, it increments this first before assigning it to y. So at this point, y is equal to 6 and x is equal to 6 if plus plus is in front of it. So it says, hey, increment x by 1 first, then look and take that value and assign it to y. Here it's saying, okay, take whatever is in the value of x first here, assign it to y, and then increment x by 1 and make it equal to 6. So notice how confusing this is, right? In industry, I would say, look, do this on the line above it and just say x is equal to x plus 1 here, then say y is equal to x. If you want to do this after, say y is equal to x, and then on the next line say x is equal to x plus 1. To me, you're trying to do too much with one line of code, and it's actually almost two different operations. So I say separate these operations instead of putting them on one line of code. But again, there's a lot of legacy programmers out there that this is the way they've always done it. They're very comfortable doing it this way. So here, yeah, perfect example. This code here, okay, I'm sorry. This code here is the same as this code here. And even I have a hard time looking at this and seeing which, so please just, if you don't know about increment and decrement operators, don't use them. Just do this. Okay. Make things easier on everybody, please. All right. But if you get it tested on it, that's what increment and decrement is all about. If it's before it, you add 1 to the variable before anything else. If it's after it, you add 1 to this variable after it's already executed the previous statement. Why, oh, why they came up with this, I have no idea. All right, so unfortunately, that is all the time I have for today. I hope that you find these webinars useful. If so, please let me know. That's what keeps me going. Either like the video or put a comment in the YouTube. Let me know. That helps me also know what you like, what you don't like. But at the end of the day, it really keeps me going. So I hope everyone's found this useful, and hopefully I will have time again soon to release another video. With that said, keep studying, and we'll talk again soon. Have a great day.